right, we're up to method number 3 on how to solve a system. So we've talked about graphing them and finding the point where they cross, because that's the ordered pair that satisfies both equations. We've substituted where that just makes sense. You can plug something in for something equal to it. Duh. Okay. And now the last one may not make quite as much sense about why you can do it. So this one, I'm going to show you why this method called elimination is actually possible. I don't care what you're doing. If you write down two things that are true, like 3 minus 10 equals negative 7, and 5 plus 4 is 9. Okay, there's two true statements. So obviously they're true. I wouldn't use an equal sign. If I add up the individual pieces of these two true statements, 3 and 5 add up to 8, negative 10 and 4 add up to negative 6, negative 7 and 9 add up to 2. Ooh, 8 minus 6 is also 2. Like, anytime you add two true equations and you combine them together like that, you will come up with something that's true. Because the left side still equals the right side. You put the left side of this one with the left side of the next one, right side of this one with the right side of the next one. Yeah, well, yeah, they equal each other. Okay? So here's what, and again, I put the steps in here. I'm not a fan of teaching steps. I think that takes all the thinking out of it, but they're there if you would like to read them. But something like this, okay, we don't want to graph it probably. We don't have a piece of graph paper. I mean, we could, but we're not guaranteed that the point where they cross would be a nice, easy to find point, a lattice point. We don't want to solve by substitution, because look what it would look like. Do you really want to plug a fraction? I mean, I can. It'll work just fine, but let's just face it. Some of y'all are scared to death fractions. So if we can avoid that, how about we do it? Okay. You have two true statements. They're true because there's an equal sign. If I add up the individual pieces, 3x and 3x, if you add up 2y and negative 2y, that's 0. If you add up 4 and negative 4, you get 0. And if I divide by 6, x is 0. And now I still will do substitution. I plugged in 0 for x because I know they're equal to each other. So 2y is 4. That means y's got to be 2. And check it. Come right there. 3 times what I said 0 is, plus 2 times what I said y was. Does it equal 4? It sure does, because that's 0 plus 4. 3 times 0 minus 2 times y, does it equal negative 4? It sure does. That's my solution. So this is handy when substitution is going to create fractions. Okay? All right, now look at this one. Now, if we add them up right now, that didn't really serve a purpose. We didn't get rid of a variable. So that's the reason it's called elimination. We're going to eliminate one of the variables. So, and you eliminate whichever one you think is the easiest. There's not a set way to do it. But see how it's 3x and 3x? Okay. If I could turn one of those to a negative 3x, then when they add up, they would go away. But you can't just change it. See, like, I didn't change this one, so I'm not going to change the whole equation. But you've learned the entire time we've been working equations that whatever you do, add, subtract, multiply, divide to one side, you do to the other. So it's like, how did you turn a 3x into a negative 3x? Well, you multiplied it by negative 1, which means we have to multiply both sides of the equation by negative 1, which will turn the 4y to a negative 4y. It'll turn the 5 to a negative 5. And then I'm going to add these up. I'm going to divide both sides by negative 2 and get y as negative 1. And then I will still be doing substitution because I'm substituting in y being negative 1. So if I divide both sides by 3, x is 3. We got it. Okay. All right, this one, I've got choices. The last two, of course I had a choice on the last one also. I picked what I thought was the easiest. This one, about the same, maybe a little different. Like, here's what's got to happen. If you want to eliminate the x's, you look at the x's. negative 10 and negative 5, what could you turn them both into? Because just multiplying both sides. Like, what if I made this one negative 10x and this one positive 10x? Then they would eliminate out, right? Okay, so I didn't change the negative 10x here, so I'm not going to change that whole equation. But I multiplied negative 5x by negative 2, which means I'd have to multiply the whole equation times negative 2, which gets me negative 46 right there. And then when I add them up, divide both sides by 15, y is negative 3. And then I just pick one of them, plug that y value back in. I pick the top one. So I'm going to add 9 to both sides. Divide both sides by negative 10, I'm going to get negative 1. So my solution is negative 1, negative 3. Now, could I have done it another way? Sure. If I had wanted to get rid of the y's, look at the y values, okay? 3 and 6, they'll both go into 6. So what if I turn this one to positive 6y and this one to negative 6y? I didn't change the second one, but what I did to the top one, what I multiplied 3 by to make it 6? I multiplied by 2. Ooh, there's x is negative 1. That's what I got the other way. And if I plugged in x is 1, negative 1. Then I'll get the exact same answer. So it's just, you just have to choose. Like for this one, 11 and 3, what's the number that goes in, that those two numbers both go into? 33. Like I would have to turn them both to 33s. However, if I choose the y's, what's the number that 20 and 4 both go into? 20. Well, one of them is already a 20. Let's do that one. But I need them to be different signs. So how about I leave the top one negative 20 and I make the bottom one positive 20. So I didn't mess with the top equation at all. And then you just ask yourself, what did you multiply 4y by to get 20y? 5. So 36 times 5 is 30. Carry the 380. Then I'm going to add them up. So x is 208 divided by 26. I don't have my calculator with me. That'll go, does it go 8 times? It does. X is 8, and then I'm going to pick the equation I think looks easier, which I think is the first one. Sorry, it's the second one. Because the numbers are smaller. Divide both sides by 4, y is 3. Got it. Okay. We're down to, oops, how did that happen? 5, 6, got 2 more. All right, this one, 4 and 5, I could turn those to 20s, or 3s and 2s, I could turn those to 6s. I'd rather turn them to 6s. So I'm going to make 6y and 6y, and then I just pick. I want one of them to be positive and one of them to be negative, because they've got to, when I add them up, I need them to go away. So just comparing, what'd you multiply negative 3 by to make it positive 6? That's a negative 2. What'd I multiply negative 2 by to make it negative 6? That's a positive 3. So I'm going to multiply both sides of that top equation by negative 2. Both sides of that bottom equation by 3. And I'm going to add them up. Negative 49 divided by 7 goes negative 7 times. Pick an equation, whichever one you think looks easier, to plug x being negative 7 into. $36 divided by negative 3 is negative 12. So x is negative 7, y is negative 12. And then last example. And remember, I'd go through these fast on purpose. You've got to pause and rewind button. Okay. All right. So I could turn the 12 and 8. There's lots of things I could turn into, like 12 times 8 is 96. I could turn them both to 96s. But I could also turn them to 24s, which is a smaller number. Or 7 and 11, I could turn those to 77s. Like, it's just up to you what you want to do. Personally, I like the 24 idea. And then I'm just going to pick one. Which one do I want to make negative? Maybe that one. So I multiplied 12 times 2 to make it positive 24. I multiplied 8 times negative 3 to make it negative 24. So both sides top times 2. Both sides of the bottom times negative 3. If you divide negative 94 by negative 47, it goes 2 times. And then, I don't know, let's pick the second one. 8x plus 11y makes 30. If I subtract 22 from both sides, I got 8 left. Divide both sides by 8, I got 1. And we're done.